Good morning to you all. Yesterday we have started our new theory class 2027 theory class physics. Yesterday we discussed our first lesson. So this recorded lesson is for the student who couldn't participate yesterday for our class, right? Today I am discussing, so I am repeating that lesson. If you couldn't come to first day, to our class, you can write down the note, and also you can solve the problems, and you can join next day, second day, that means next Sunday 12:30 at knowledge week, right? First I'll give you a brief introduction about our syllabus, right? In our syllabus we have 11 units. So this is our first unit, that is measuring, right? So today we start discussion about our first unit, right? You are given two tubes, so you can collect that from knowledge being count also. So we use this tube to write down the notes, right? There you can write your notes, and also this is homework book. You are given additional questions as homework in this tube, right? So if you are not having this tube now, you can write your note in your notebook. So after that, after having that tube, you can rewrite the note, right? Okay. So today we start our unit number 1, measuring, right? So at first we discuss about physical quantities. Write down subheading physical quantities. So if you have the tube, you can write down the notes here, right? So there you have enough space to write the note, right? So okay, so what is physical quantity? Right, now when we consider an object, right? An object means any item, right? That can be a vehicle, a person, anything, right? So when we consider any object, there are some quantities we can measure, right? For example, we take a vehicle, right? We can measure speed, right? We can measure distance traveled by the vehicle, distance, and we can measure time taken by that vehicle to travel from Kandy to Colombo, time. We can measure mass of that vehicle. So all these quantities we can measure correctly, right? So these quantities we know them as physical quantities, right? Okay, right. For another example, if we take a person, right? So can we measure hate? Right? Can we measure kindness? So those are not physical quantity. We can measure weight, mass, speed, such things, they are physical quantities, right? Okay, write down. When we consider an object, there are some quantities we can measure numerically. They are known as physical quantities, right? So today we can write some examples. Okay, write down distance speed, put commas and write down. Speed, force, energy, electric current, wavelength, frequency, specific heat capacity. Right, that's enough. We have lot of physical quantities in physics, so you can the command write down etc. Right, we have a lot of. Okay, right. Then after that we move to our next topic, right? That is SI units. SI units. Okay. Right, these are international system of units. Right, so this is the next topic. So what are SI units? Now think that when we measure one quantity, we have lot of units, right? For example, now think about distance, right? There are lot of units to measure distance, right? Kilometers, meters, miles, then light years, right? Likewise, lot of units are there, right? But in international communication, it is difficult. We find difficult when lot of people using different units, right? Therefore, we choose one of them as SI unit, right? So for a given quantity, we have one unit. So that is the SI unit. That is what we use internationally, right? So okay, write down. When we consider a physical quantity, there are several units to measure same quantity. Sometimes we find difficult in communication when we are using several units for one quantity. Therefore, scientists agreed to have one unit. For one physical quantity. They are known as SI units. Right. Okay. Then right now in some countries they have their units for measure distance or the things, right? So sometimes we don't know them, right? Then Lankavet එහෙම තියෙනවනේ. For example, you think that දැන් හිතන්නකෝ මිනිස්සෙක් ඇවිල්ලා පෙරදිනේ ෆොරින් කෙනෙක් ඇවිල්ලා ඔයාලගෙන් අහනවා බොටනිකල් ගාර්ඩන් එක තියෙන කොහෙද කියලා. හොඳ ඒ ළඟ හරියට දහන්න හිතන්නෝ. ඒත් අපෙන් දැන් කියනවා හුවක දුරින් කියලා ඩිස්ටන්ස් මෙෂර් කරන යුනිට් එකක් තියෙනවා, right? ඒත් අපි කිව්වොත් හුවක දුරින් තියෙන්නේ කියලා ෆොරින්ට තේරෙනවද? නෑනේ. නේද? ඒකට අපිට use කරන්න වෙනවා international system එකේ unit එකක්, right? Okay, then right, then they write down next subheading, that is fundamental physical quantities and fundamental SI units so we call them base units also, right? So if you have this tube, you no need to write this again, right? I'm just writing these topics here, right? So we discuss about physical quantities and SI units, right? Now you think that you are having a small book and you are writing physical quantities. That is the udayanga අවසරකම් ඔයාලට ඔන්න මම කියනවා physical quantities මතක් වෙනවා ලියන්න කියලා. එක sections, right? කොච්චර තියෙද, right? There are lot of physical quantities, right? So out of this number of physical quantities, we have 7 fundamental physical quantities, right? We call them fundamental because other physical quantities are derived using these, right? Therefore we call them fundamental physical quantities. So we have 7 fundamental physical quantities, right? Okay, write down. There are number of physical quantities in physics. There are number of physical quantities in physics. Out of them we define 7 fundamental physical quantities. 7 fundamental physical quantities, right? Highlight that, 7 fundamental physical quantities and 2 supplementary physical quantities. Highlight that also, 2 supplementary physical quantities, right? Okay, so the physical quantities ගොඩාක් තියෙනවා. එකේ 7 physical quantities තමයි fundamental and also 2 supplementary physical quantities, right? Okay, then I'm going to have a table and write this. So before that today, that in that previous topic, highlight that we defined what is physical quantity. There you have written that, highlight this. There are some characteristics we can measure numerically. Highlight that word, right? So in the second topic, the SI units, you wrote that there is 1 unit for 1 physical quantity, right? Highlight that words also, right? Then we are going to have a table. Right, so these are the physical quantities: length, then mass, time, temperature, electric current, amount of substance, and luminous intensity. Right. So these are the symbols: meters, kilograms. Right. So you need to consider about simple capital letters. Right. These are simple letters. And time, seconds, simple s. Don't write capital S because we have another unit for capital S, that is a unit of conductivity, right? So Siemens, don't write that. So temperature, Kelvin, capital K. Then electric current, amperes, capital A. Moles, you know. Luminance intensity, we call that candela. Right, these are the 7 fundamental physical quantities and base units. Right, copy down. Right, so this is 2 supplementary physical quantities. Right, this one plane angle and the other one solid angle. Right, so you know about these plane angles, right? In mathematics you have used that angles theta, likewise. So you have used that usual as the usual unit degrees, but SI unit is radians, right? Simple R radi, that is the notation. Then stir radian, that is SNR, right? So these are 2 supplementary physical quantities, right? Then write down. Following table shows 2 supplementary physical quantities. Following table shows 2 supplementary physical quantities. Right, copy down this. Right, so after writing this, here you have a dotted line in your tube, right? Under that table, write down. So after this lesson, we discuss about dimensions. But we write, right? Okay, write down. Supplementary physical quantities do not have dimensions. Supplementary physical quantities do not have dimensions. They have units only. They have units only. Right. So they highlight that sentence also. Right. Then we move to first question of your tube. Right. Which of the following is not a fundamental SI unit? Right. In tube that word is missing. Please write that. So you can see here we have answers, right? Then this is kilogram, fundamental SI unit, meters also, seconds also, amperes also, but this is not Kelvin, right? This is simple K. This is a prefix. This is kilo, right? This is not a unit. You better put an arrow and write that. This is not a unit, it is a prefix. Kilo, right? Okay, so answer is 5th one for first question. Then we move to second question. Right, then this is the next question. Which of the following does not represent fundamental unit in SI system? Right, now, okay, now you can see all of them are SI units, right? All of them are SI units. But now Newton also SI unit, but that is not a fundamental unit, right? That is not a fundamental SI unit. Therefore, answer should be second one, right? So we can write here, put an arrow and write this is an SI unit, but not a fundamental SI unit. Right, then we move to third one. Right, this is the third question. Which of the following is not an SI unit? Right, we know that all these are SI unit, but this one is not the SI unit of length or distance. It should be meters. Therefore, answer fifth one. Right. Okay. Right. Then today we move to our next subheading, that is derived physical quantities. Okay, write down next subheading. Okay, write down. This is the next subheading. Now we have discussed about 7 fundamental physical quantities, then about 2 supplementary physical quantities, right? So all the other physical quantities, right? All the other physical quantities, they are derived physical quantities, right? Ara physical quantities tika ara ituru ewa okkom monada derived physical quantities, right? Okay, write down except except 7 fundamental physical quantities, except 7 fundamental physical quantities and 2 supplementary physical quantities and 2 supplementary physical quantities. All the other physical quantities are derived physical quantities. Right, so they highlight all the other physical quantities are derived physical quantities. We call them derived physical quantities because these physical quantities are derived using fundamental physical quantities. Right. So today I'll give you an example, no need to write. Now volume is a derived physical quantity, right? Now you can consider volume of a cuboid, right? Then how to find that? We need to multiply length, width and height, right? So all these 3, they are lengths, right? These are length. Right? So the derived physical quantities develop using fundamental physical quantities, right? That's why we call them fundamental physical quantities, right? Okay. So we write some examples. Write down examples. Write down speed, comma, force, comma, frequency, comma, energy, comma, specific heat capacity, comma, etc. We have a lot of there, right? Okay. Okay, then Budaya, we discuss about derived unit. Next subheading, this is the next subheading, derived units and derived unit and SI unit, right? Now, when we consider a physical quantity, right? For example, we take force, right? So we can write a unit with only that fundamental units, right? Using only that fundamental units. So that is kilograms ms minus 2, right? So this is having only fundamental units, therefore we call that derived unit, right? Make it right? We use single letter, single name for that. That is taken as SI unit, newtons, right? This is the SI unit then. So these are examples, right? So sometimes, now mostly that SI unit and derived unit both are equal to each other for some physical quantities, right? For example, if we take velocity, right? Velocity, then derived unit ms minus 1, then SI unit also same, right? Okay, we'll discuss that. First write down the definition. Derived unit has only fundamental units, sometimes derived unit and SI unit are equal to each other. Derived unit and SI unit are equal to each other. And also in some situations, they are different. Right, so would they highlight that derived unit has only fundamental units. Highlight that derived unit has only fundamental units. Right, so we go through some examples, right? We start, we write the topic first, okay? Okay, before that today you have yes, there is a special note there in page number 2. Rules should follow when writing derived units. Rules should follow when writing derived units. Right. So first one, there should be a small gap today. There should be a small gap between that fundamental units when we writing, right? Okay, write down first one on that dotted line. Write down. There should be a small gap between. There should be a small gap between two fundamental units. When writing an expression for derived unit. Okay, there you have a small box. There you can write some examples. Now here, kilograms, ms minus 2, right? You can see when I am writing this, I am not writing like this, right? Right? We are having small gap there, right? Buddha gap small gap, right? Then ms minus 2, likewise. Then kilograms per meter, right? Lot of examples are there, right? Okay, kilograms, meter square, s minus 2, likewise, right? Okay, this is the first rule. Then another one, right? Actually there we have, that is not the rule, right? Something like tradition, right? When we writing a derived unit, first we write kilogram, right? Kilogram is the mulling, right? Okay, write down. When we write a derived unit, we write kilogram first. We write kilograms first. Okay, for that also you can write some examples there. Kilograms per meter, right? Then kilograms meter squared is minus 2, likewise. So we write kilogram first. Right, then today write down next subheading. ඔයාලගේ ටියුට් එක තිබ්බත් මේක මේ note එකේ තමයි පිළිවෙ. Right, ඔයාලගේ notebook එකේ. Okay, write down finding units of a derived physical quantity. Right, first one, volume. Right, you can write any expression, right? You know any expression to find the unit, right? So here we can write volume. Now this is length, breadth and height, right? Then volume is equal to length into breadth into height. So we can consider unit. So you need to write every step, right? Considering units of volume, that is equal to units of length, that is meters, breadth, that is meters, height, that is meters. Then we have cubic meters there, right? So sorry, here we have only that are fundamental units, therefore this is the derived unit. So here we can write derived unit, that is cubic meters, and also SI unit, cubic meters, right? Right, then with the second one, velocity. I think you remember definition for velocity, right? That is displacement divided by time, right? This is velocity. So we can consider units. Considering units, right? We can write units of velocity. What is the unit of displacement? That is meters. Time, unit of time, that is seconds. So here that power is 1. When we take that to numerator, that becomes minus, then ms minus 1. Right? So there ms minus 1, that is the derived unit, and also SI unit also same. Right, then next one, third one, we write acceleration. Right, so I think you remember definition of acceleration. Acceleration is equal to change of velocity divided by the time taken. Right, now we can consider unit. Considering units, we can write units of acceleration right. Now change means change also have that units of original quantity, right? Change of velocity kiwama velocity wala unit ma tama, right? Then that is ms minus 1 should be divided by seconds, right? This is power, that power is 1. So we can take that to numerator, ms minus 1 into s minus 1. So that becomes ms minus 2. Right? So derived unit is ms minus 2. And also SI unit also ms minus 2. Right? Then fourth one, right, that is we write yes, force. Fourth one, force. Right, we can write an expression for force using Newton's second law, right? You also know this. Mass simple M, when we give external force capital F, acceleration simple A, right? So F equals ma, that equation we can use to find units of force, derived units. Right, so I can write considering units. Right, units of force, that is equal to units of mass, you know, kilograms, then units of acceleration ms minus 2, then this is the answer, kilograms m s minus 2. Right, so this is the derived unit. Right, derived unit kilograms ms minus 2. Right, then make diga වැඩි නේ. ඒකින්ද සයන්ටිස්ලා ඩිසයිඩ් කරා අපි මොන හරි මේ ලොකු සේවයක් කරපු කෙනෙක්ගේ නමක් දාමු කියලා නේද ෆිසික්ස් වලට. ඉතින් මාගෙන් කතා කරලා මම එපා කියලා කිව්වා. ඒ නිසා නිව්ටන්ගේ නම දැම්මා. Right, so that is Newton's, then that is the SI unit. Right, this is SI unit. Okay, right, then fifth one, pressure. There we have definition for pressure. Right, force is there, area is there, and we can write pressure P is equal to F over A. Right, so we can consider units today. Considering units, we can write units of pressure equals units of force. Now we don't write here newtons because then it will be difficult to find derived unit of pressure. When newtons කියන්නේ fundamental unit එකක් නෙවෙයි. right, then we need to write derived unit of force here. ms minus 2 should be divided by meter square, right? That is a unit of area, right? So I simplify here. මෙන්න මෙහෙම පොඩි වැඩක් කියලා දෙන්නම්. Now you think that we need to simplify this x divided by x square, right? That means x divided by x into x, right? You can cancel this next, then you will have 1 over x, right? මේක මෙහෙම කරන්න පුළුවන් නේද එකපාරම මෙහෙම දුරට යන්න නැතුව. You can do this and you get the same answer, නේ, right? අපි ඉස්සරහට එහෙම කරමු. දැන් ටික ලොකු ළමයි නේද, right? Then here we have 1 kilograms. When it comes to numerator, that becomes minus 1 and s minus 2, right? So this is the derived unit. This is derived unit, and SI unit, that is also different. Instead of this, what we write Pascal, right? Okay, copy down. Right, then the next one, density, right? We use notation rho. This is a Greek letter for density. So we can write density is equal to mass over volume, right? Density equals mass over volume. So we can consider units. Considering units, we can write units of rho, that is equal to units of mass, that is kilograms, and should be divided by units of volume, that is cubic meters, right? We can take that to numerator, kilograms per cubic meters, right? So this is derived unit, right, as same as SI unit, right? So this is SI unit also. Right. Right. Then seventh one, work and energy. Right. May then work energy. Then අපි එකට තමයි ලියන්නේ. Right. මේ දෙන්න හරියට නිකන් බාත්‍ය සන්තුෂ් වගේ කියලා මම විද්‍යාර්ථණන් හරි. Right. The reason is they have same units. They have same derived units, same SI units, same dimensions. All of them are same. Right. Okay, so at first we consider work, right? So we take the notation W. Now you know in all levels this definition, when we are giving a force, right, to an object, if our displacement is simple d, right, we can write W is equal to F into d, right? So considering units, right, considering units, we can write units of W equals kilograms m s minus 2 derived unit, and right, displacement, that is meters. So the meters there, here also meters there, you can multiply that, right? That power is 1, when multiplying they are adding, right? Then kilogram, meters per second, this is the derived unit, right? Not per seconds, ms minus 2, right? So this is the derived unit, right? So this is the derived unit with fundamental units only. So instead of that we use SI unit, that is joules, right? Okay, so before discuss about energy, right? We can discuss another method to find SI unit, right? Okay, write down not another method to find SI unit of pressure, right? Okay, now this is the definition. P equals F of A, considering units of pressure. We can write units of force Newton and meter squared. We can take that to numerator, Nm minus 2. So instead of that we can write joules. So this is the SI unit, right? So this is the second method, but disadvantage of that method is we can't find directly derived unit of pressure, N, right? Newton, this is not the derived unit because that is not the base unit, right? Okay, so but anyway we need to know this method also, right? Copy down this, and also we have this type of method to find units of work, right? Write that also. We use that same expression. Sorry. W equals F into D, displacement. So considering units, we can write units of work, Newton. We can write Newton here. Units of force, then units of displacement, that is meters. So we have Newton meters here. Instead of that we can write joules, right? So here also we have that disadvantage. What is it? We cannot directly find derived unit using this method, right? Okay, then we move to our next quantity, right? Then energy, right? Calling value work name Bhathiya may Santushwagi, right? Then energy, we know different types of energies, right? Potential, gravitational potential energy, kinetic energy, right? So you can use that any expression for that purpose, right? So I am using here gravitational potential energy. So we consider a mass at a height of simple edge, right? Then we can write expression for energy. We take that as E, right? Energy equals gravitational potential energy mgh. I think you remember that expression. So considering units, we can write units of energy, units of mass, that is kilograms. This is for the gravitational acceleration. G means gravitational acceleration. So that is acceleration, right? Therefore, unit ms minus 2. Then height, that is a length, therefore meters, right? So you will have kilograms, meter into meter, meter squared, s minus 2. This is the derived unit, right? Derived. And also we can use joules as SI unit, right? Make a work වගේමයි එකයි බාහිර සන්තුෂ්ඨ වගේ කියලා කිව්වේ, right? So this is gravitational potential energy. If you use kinetic energy also, you can have the same one, right? Okay, right. Then next one, power. So over there, power is rate of doing work, right? Then we can write power P is equal to work or energy divided by time. This is the definition. Considering units, we can write units of power equals work. We can write units of work, derived unit kilograms, meter square s minus 2, right? It should be divided by seconds, right? Okay, so we can take that to numerator, kilograms, meter square s minus 2 into s minus 1, right? Here that becomes minus 2 minus 1 minus 3 kilograms, meter square s minus 3. So this is the derived unit, right? This is derived. Okay, right here this is derived unit. Okay, so instead of that we can write SI unit, power bulbs watts, right? That is the SI unit. Okay, copy down this. And also then we discuss another method, right? We discuss another method to find SI unit, right? Okay. Okay. Then another method to find SI unit. Right, now power equals energy divided by time. So we can write, considering units, we can write units of energy, that is joules, right? Then seconds. So we can take that to numerator, joules per second, right? This can be replaced by watts, right? This is the SI unit, right? So in this method also, this alternative method, we have the disadvantage. What is it? We cannot find directly derived unit, right? Joules, right? Then to the final quantity, that is frequency. So we use the notation simple F. So there we have a definition for frequency: 1 over periodic time, reciprocal of periodic time, right? Then considering units, we can write units of frequency, that is equal to 1 over, now that is a time today, then that is seconds, right? So we can take that to numerator, that becomes s minus 1, right? So this is derived unit, right? So instead of that we use SI unit, that is hertz, right? Okay, so now you know how to derive units for a given derived physical quantity, right? Right, try to do this yourself, right? Right? So these are the things today we discussed at first day. So you can join next day for second class, second lesson, right? We continue from this point, right? Okay, so I'll give you some homework. in your tube, right? So right, you can try in this tube, you can try until question number 10, right? And also at page number 10 you have basic mathematical knowledge needed for physics. So there you have an exercise, right? Please try it and come next day. I'm going to check that also. And here you have next page, first day homework. So there you can do first question, fourth question, ninth one, and 10th question, right? You can try them, right? After that, homework, that homework book, this one, right? There, first page you can do, right? First page question you can do that, right? And second page question number 4, 5, 6 you can try, right? And after that, is that enough? Right, so in this one also, question number 2 I am going to discuss, yes, 2 of them. Right, with a workbook එක ගන්න. ඒකේ second question එකේ lines තියෙනවා. පළවෙනි line එක, second එක, third එක, fourth එකේ තියෙන මේක පොඩ්ඩක් අර එහාට පැනලා තියෙනවා, right? Fourth one there should be s minus 1, right? S minus 1 and dotted line, right? And final line also, right? Right, make it eenne s minus 1, and here you have Newton meters, like that, right? Then next line, that is okay. Last line should be like this, meters per second, and this is correct, right? So these things you have to correct, right? Printing mistakes, right? Then in third one, finally I am going to discuss this one. Third one, write down derived unit of following units. Right, make a month dekak discuss class again. So I'll do that also. Newtons per meter. Right. No, so now we need to write derived unit. Now, what's the problem here? This is not derived unit because this is not a fundamental unit. Then you need to substitute fundamental unit instead of newtons. You know that. What is it? Kilograms ms minus 2 multiplied by m minus 1, right? So here we have m to the power 1, here m to the power minus 1. You can cancel that, then you will have kilograms s minus 2, right? I'll do another one more, right? Okay. Right, there you have watts per meter per Kelvin, right? So here watt is not a fundamental unit, right? So you need to write derived unit for that, right? Then for that we can write kilogram meter squared s minus 3, and here we have m minus 1, k per Kelvin, k minus 1. So put here meters, power plus 2 minus 1. So you can add them. Adding means plus 2 minus 1, that is plus 1. Kilograms m to the power 1, right? Then s minus 3 and k minus 1 is there, right? This is the answer. So likewise you can try other questions also, right? So do your homework, right? Homework tick කරන්න හදපු ගණන් ටික අපව හදන්න පළවෙනි දවසේ ඉඳන් වැඩ ටික හොඳට කරන් යන්න. මම ක්ලාස් එකේ පෙන්නනවා අපේ island ranks district first වෙච්ච ළමයි රිසර්ච් මම ඔයාලට පෙන්නුවා right ගිය අවුරුද්දේත් අපේ biology district first එකේ ඉන්නවා ඊට කලින් අවුරුද්දේ maths වල district first වෙච්ච අයියා ඉන්නවා එතකොට එයාලගේ වැඩ කරපු විදිහ මම කිව්වා right එතකොට ඒ වගේ හොඳ රෑන්ක් එකක් ගන්න මේ මුලින් ඉඳන් ඔයාලා පළවෙනි දවසේ ඉඳන් වෙන මුකුත් කරන්න නැහැ මං කියන වැඩ ටික කරා නම් හරි හදපු ගණන් ටික ආපහු හදන්න හදපු අය ඔයාලා මං හදනකොට මං හදපු එක බලාගෙන හැදුවා නම් ඒක ආපහු පාරක් ඒව සෙට් එක ආපහු ගෙදරදී හදන්න right හදපු එකක් හැදුවා කියලා කිසිම පාඩුවක් කාල වෙන්නේ නැහැ මමත් ඒ ලෙවල්ස් වලදී කරපු පුරුද්දක් තමයි මම වාට කියන්නේ then second one do all the homework දැන් මම ඔන්න homework set එක කිව්වනේ ඒ ටික ඔක්කොම කරන්න ඊළඟ next week වෙන්න කලින් එතනින් එහාට මේ තියාගන්න එපා මේ හිඟ වෙච්ච ණය තියාගන්න එපා ඊළඟ week එකේ කරන්න ඕක ගොඩ ගිහලා වැඩේ අවුල් වෙනවා right ඒකින්ද ඒකත් කරන්න ඔය වැඩ ටික කරගෙන next week class එකට එන්න you can join the class next week right so next Sunday don't miss the class next Sunday 12:30 knowledge win we have our class so they send the message to your friends also pass this video to them also so they can write the note and get prepared and they can come to next class they can join with us right එහෙනම් අපි හොඳ වැඩක් කරමු ඔයාලගේ දැන් කලින් බැජස් වලත් අහලා බලන්න අයියලා කලින් අපි හොඳට වැඩ ටික කරගෙන ගිහිල්ලා අන්තිමේ ඔය එන රිසල්ට් එක තමයි මම ඔයාලට පෙන්වුවේ පළවෙනි දවසේම කොහොමද අපේ රෑන්ක්ස් ටික කියලා. ඉතින් මුලින් ඉඳලම අපේ වැඩට හොඳට සෙට් වෙලා වැඩ ටික කරගෙන යන්න. right I wish you good luck.